I'm with the Indata Foundation, and I will speak about a new line of research that we recently started. Maybe you're already familiar with our project. We usually study the internet from the point of view of the Russian autonomous systems. And since the internet is a global phenomenon, we are trying to take a Russian perspective on this global structure. Some time ago, we published research of the services available at RUnet, and now we have this new project where we study how DNS projects IP addresses to the autonomous systems. It will become clearer as I proceed with the presentation. It is also a service in a way. Anyway, I will first describe the scope of our research. After that, I will show you the results, and I will explain the method by looking into its performance, into its results. We actually plan to publish most of this data on our website. There will be a lot of graphs. They are not very visible on the big screens, but when we publish the reports on the website, it will be more interactive and it will be easier to review. So what we study, I don't want to explain what DNS is. I'll just remind you that for the in every domain zone, we have this such a thing as the authoritative name server. It's a server that contains information about the names and is authorized to answer to the requests for the names. We find such authoritative servers for the second level names in .ru, .su, and .rf. So we find those NSs, name servers, and we retrieve A records. Usually they are web and MX records. MX stands for mail. And we want to build relations between the autonomous systems from the following perspective. We need to understand in which autonomous systems every authoritative NS resides, and to which other autonomous systems, maybe other autonomous systems, the DNS records point for the zones that are regionally hosted in the autonomous system. So to keep it simple, so we've got a test.ru zone. Its authoritative name is ns.test.ru. We retrieve that name, we identify its A record, we identify its IP address, and we match an autonomous system to this IP address. Besides, we're also looking into indirect dependencies. Indirect dependencies are also possible. They're generated by a DNS in the same zone, in the test.ru. The name of the authoritative NS is ns.example.com. Then we can take the example.com part. We will find its own authoritative NSs, and then we'll be able to match an autonomous system to the IP addresses responsible for the example.com authoritative NSs. It may not be very straightforward, but we've got this dependency, and if you control the IP addresses in this second autonomous system, then you will control test.ru as well. So it's an indirect dependence. A records, I think you understand how it works. We identify authoritative NSs, we identify records for a mix. A mix should state a name, we identify the IP address, and we also find the autonomous systems that will show us A records and mix records on the basis of their IP addresses. And as a result, we have this graph. An autonomous system is the starting point, an autonomous system with an authoritative NS. And the connected autonomous systems to them would be the ones shown here to the right. It is to the right of you. So the dependencies will be the resources for MXs and As and the second order dependent systems. What input data do we have? Well, we start with about 5.5 million zones from .ru, .su, and .rf that are resolved somehow. That is to say, we managed to identify at least NSs within those zones. We also have 471,000 of distinct IPs or unique IPs. That's not hosting, that's all IPs, including IPs of NSs, IPs of MXs, and hosting too. When I say hosting, I predominantly mean A records. A records per se account for about 280,000 records, usually, or IPs. Usually, a lot of websites are connected to the same IPs, regular practice with hostings, and that's how we arrive at 11 names per IP. There are about 8,500 autonomous systems, unique or distinct autonomous systems, and in terms of country codes, we see about 100 of them, which is a lot in my point of view. If I'm not mistaken, all in all, we have about 250 countries, and the internet penetration is not the same everywhere. So 100 of different countries, country codes, that means a significant batch of the world with good internet penetration. This is WHOIS data, and the geography identified in WHOIS is not always precise, but we don't have any other data, so we make do with what we have. Now, let's look at the data. And this is the first more obvious rating that we can build. This is a rating of autonomous systems that contain IP addresses of authoritative name servers. They are the ISs that do not host websites. They host DNS. By controlling the DNSs, of course, you can control everything that takes place inside that domain. And this rating, well, the number of zones is multiplied by the diversity of NSs and their IP addresses. So this rating is not, again, it's not obvious, it's not trivial. Reg group here is in the second place, but it's a major registrar, but BigGet is in the first place. It's higher in this rating because the diversity, they are addressing diversity is greater for BigGet. And I'm using bold font to identify foreign autonomous systems. So basically, you see that mostly we see Russian companies here. Some of the companies in the rating are foreign, like Cloudflare and Hetzner. There are a lot of small hosters, not really hosters, but people who keep ASs for themselves, and they place authoritative NSs there as well. And Cloudflare, I think it needs no explanation. They have a huge DNS hosting. We'll meet Cloudflare again in those ratings. And to the right, you see indices, routes. Fraction, kind of. To the right are routes from route servers, and to the left are global routes. When I say global, I'll explain what I mean by global a bit later. And this is a more standard rating for autonomous systems that shows the number of zones hosted by this or that autonomous system. This picture is much more familiar. Leading registrars are leading, and then eventually we end up with hosting providers. And the routes are the same. And where it says nil, it means that those three autonomous systems are not present at the IXs, at the traffic exchange points, like MSK IXs from which we get data, but there are other IXs as well. You can look up the list of those IXs on our website. Nil means that those autonomous systems, since they are foreign, international, they are not present at the route servers. We didn't find the routes at the route servers of the IXs, but not Cloudflare. Probably you all know that Cloudflare has its presence at the IX. As to the diversity of the routes, this is a screenshot from our website. We have a section there that shows the connectivity graphs between different autonomous systems. And this is RUnet 48. It's in the second place here. So it's 18 by 14. It means 18 full view biggest operators there to the right, and to the left are route servers. And you can see that, well, to the left, like 6 autonomous systems, those 14 different routes. They are all rearrangements of those autonomous systems. 14 is good connectivity. 14 is a lot, but Cloudflare, for them, they beat everybody else on global connectivity, 358. And another rating for those indirect dependencies. This is quite an insightful information. I'll try to explain why it is insightful. These are authoritative analysis of some other zones on which the studied zones depend. And here in the 7th and the 8th place, you see CNIP AS. This is RUnet, in fact. RUnet that's used by RUnet for provisioning, for ensuring the stability of its own domain name stability. And RUnet is provided via this autonomous system. So these are indirect dependencies. If we go back over here on this rating, you see no CNIP if you look at direct dependencies only. But if you look at indirect dependencies, we see this new feature, and we begin to understand who depends on whom. Yandex is in the last place. Well, people are usually surprised to see Yandex here. In fact, Yandex has a very old DNS hosting facility. People tend to forget about Yandex, but I think they were one of the first ones with DNS hosting. It's mail for the domain, and there are a lot of domains, many zones actually, in the Russian domains that are still hosted by Yandex. And now let's turn to the graphs. The graphs are quite busy. They are very rich. This is an attempt to visualize all of RUnet. These are autonomous systems. I will zoom in later, but this is not BGP-related autonomous systems. This is connectivity, kind of quasi-connectivity. Well, it has no direct bearing on BGP, but this is connectivity where in one autonomous system there is an authoritative name server or servers, but the record points to a different autonomous system. What we can tell from this graph is that there is a core in the system. It's quite distributed, but if you look inside, you will not get any surprises. You will see Russia's leading, and not just Russian, because Google is also there. They are leading and biggest providers and hosting providers. This graph, of course, is centered on connectivity. The more connections between the different nodes, the higher gravity they gravitate towards the center. That's why we see this kind of structure. And on the edge, we see like isolated clusters of autonomous systems, a couple of autonomous systems. Somebody keeps an SMX and hosting all in the same place, and they point to each other. And in the majority of cases, if we deal with such a closed cluster, usually we will also see a loop there. They are autonomous systems that keep everything to themselves. There are many clusters like this, but there are more zones than such autonomous systems. Most of RUnet is concentrated in this core that you saw on the previous slide. And this is about geography. This is autonomous systems by the number of zones and IPs of authoritative name service. This is where DNS lives. And the conclusion is that mostly DNS lives in the Russian autonomous systems. However, there is another 27%, which is not too much. On the other hand, it's quite a share. 27% is zones located in international foreign systems. The same graph, but using A records. This is hosting. A similar picture. And yet more than 1 million resources are located, or they point to a foreign system. It doesn't mean that they're necessarily located physically in a foreign location. It may be a foreign autonomous system, but they could have a site here in Russia, a domestic site. So what else can we do with this data? This is a rather typical picture. This is a big registrar. I think it's VGRU. I can't tell. I don't see what's written in the middle. But there are A records pointing to this registrar. A records in the autonomous systems of this registrar. It's a tree. A registrar points to some autonomous systems with hosting. This is indirect dependencies. And it is indirect, you can tell. I have very little time left. I will skip some slides. I just wanted to give a bit more time for DNSSEC. And this is quite an interesting dimension. We can take an autonomous system which receives resources, and we can build a graph of autonomous systems. And in this case, the source is autonomous system with authoritative NSs, and MXs point to Google. They are ASs that use Google applications. And this is DNSSEC. DNSSEC is the technology that protects information from being substituted for other information. It works pretty well, as practice demonstrates. This is a rating of ASs with valid DNSSEC zones. This is multiplied by NSs. That's why you see big numbers here. And most of valid zones in .ru, .rf, and .su, there are more than 3,800 of valid zones. 3,500, sorry. RT-COM AS is in the first place of this rating. The reason being many hosting providers use this autonomous system. The equipment is in the data centers, and DNSSEC is provided through those authoritative service. Cloudflare, I think you know how much they support DNSSEC. Amazon is a curious case. Amazon has its own service, Route 53, which is a DNS hosting, but it does not enable DNSSEC. However, many keep virtual instances with Amazon where they place authoritative service that do support DNSSEC. This was the source of sources of data, the literature, so to say. And now questions. Do we have any questions, please? Questions? Yes, please, go ahead. Don't forget to introduce yourself. Pavel Kina from the Moscow Aviation Institute. Yes, Pavel, we'll start from this side, if you don't mind. Sure. My name is Andrei. When did you start collecting the statistics? I'm asking this question because what I want to know is, I've seen DigitalOcean and Hetzner. And we know that at the time when Russian authorities were fighting Telegram, both of them were closed and they are not still opened or fully opened. And yet Russian servers are there. So, I mean, what are these people thinking about? How do clients find them? That is to say, how do clients reach them? I mean, I probably can imagine how things are today, but what about dynamics? Can you tell us how it evolved since the campaign against Telegram? Yes, this is March data. This is from March, when DigitalOcean was blocked. I mean, the servers and there were lots of their servers blocked by the Russian authorities. We saw that they were blocked. As to what people were thinking, if they kept their stuff with digital, probably they liked DigitalOcean so much that they placed their authoritative NSs with them. I don't see any problems there. Maybe because of block, maybe they were. I mean, the clients, they are more focused on foreign markets, foreign clients, maybe. But NS IPs, there are not that many. Mainly those who kept web stuff suffered. But NS is a very constant. What about mail? Mail, yeah, mail, including mail. Well, it shows that. I mean, even if a resource is blocked, the clients stuck with the DigitalOcean and never went away. I've got two questions. The first one. Russia is a big country. Connectivity depends on the region. It differs from region to region. In the very early days, all traffic went through Moscow. Did you study traffic paths today? What's happening to traffic? And the question was from Pavel Kena, Moscow Aviation Institute. Yes, this is an interesting question, and we have it in our plans. This will be probably our next research project, because I did not talk much about BGP, because if you need to understand that, you need to understand BGP type of connectivity. It doesn't bear directly on DNS. You don't use BGP to analyze the connectivity of autonomous system with DNS is an autonomous system with A records, the values of A records. But if you take an autonomous system of the user, then yes, it's something that we would like to research how the users are connected to those two autonomous systems, because first the provider of the user has to get to the authoritative NSs to identify the addresses, and after that you have to get to the autonomous system, which is, say, DigitalOcean, and it is blocked. And you won't be able to get any data from it. You will not be able to see anything there, maybe because it is blocked. But it is in our plans, yes, so yeah. And a question about blockings, actually, this is a different question, but it will be a third one. But I wanted to ask a second question. But you can wait for my presentation. I will be discussing connectivity later. Excellent. Okay, another question then about parkings. Domain parkings is a separate ecosystem. And traffic moves to parkings in a slightly different fashion. I mean, did you differentiate between park domains and all other websites, like when you did the counting of the statistics? Well, not here, but it would look like something that you see here in the topmost left corner. You will see a couple of autonomous systems. One of them will have web, the other NS, and they will point to each other. They will be looking at each other. So yeah, it will be like an island, like an isolated cluster. Usually, very few IPs would be used there, but there would be a lot of zones there. But I think that, yeah, we will do a study like this as well. And one last question. Yes, thanks for the presentation. Very interesting. A question. In 2018, in June, there was a scandal between Biget and Reg.ru. Do you have any data? Was there any dynamics of like any movement that? My name is Boris. I'm from Korsoft. No, we did not. We didn't want to analyze that particular period of time because we were interested in DNS, but domain migration should be analyzed with who is data. You should look at the re-registration of the registrar. So to say, I remember this kind of movement to which you refer. This kind of migration. I remember that thing, but. Yeah, so maybe. Okay, one very last question. in this research, do you have like timestamps or a timeline? No, it's our pilot project. No, we don't have enough data to build something like this. Right. Thank you very much. Thank you. This is.